Live.
Intro music. I was ready to really groove.
I was counting on it, honestly.
Yes.
There you go. Hey, folks. Hello and welcome to another Buoyant Service Mesh Academy. This time we are hands-on with Linkerd Enterprise. I'm Jason. I'm a technical evangelist for Buoyant, so it's my job to talk to folks about Linkerd and why it's awesome. In this case, we're going to talk about Linkerd Enterprise. And William, do you want to introduce yourself?
Yeah, I'm William, CEO of Buoyant, and I'm the person who likes to talk, but I'm just going to do some of the talking today.
Excellent. Yeah, and today William, we're gonna show folks what this enterprise Linkerd distribution is and how they can get a hold of it.
Yes. Oh, that was a question. Yeah, absolutely.
Yeah, that was. Awesome. Okay, and you've got some slides for us?
Sure do.
All right, awesome. Let's go ahead and get started.
All right, cool. So, we're going to do slides for like 5 minutes, maybe 10 max, and then we're actually going to do a hands-on portion because my goal is to get people actually using this thing. We've got a little trial set up where you're going to get access to Linkerd Enterprise for a couple of weeks, and you'll be able to play around with it in the safety of your own Kubernetes cluster. So I'm going to go through kind of what Linkerd Enterprise is and how to think about it and how it relates to open source and all that stuff. If you want to follow along at home, and I'm going to show this slide again in like two more slides, just to remind you, we have a repo here that you can go clone with a lot of the instructions. And then the three things you're going to need, maybe four things. You're going to need a functioning web browser. You're going to need a Kubernetes cluster. Okay, K3D is one that I use because it's easy and you can run on your Mac. If you want to play with some of the fancy zone-aware routing features, then you're going to need a multi-zone Kubernetes cluster. And I think in this Git repo here, we actually have a K3D config that will allow you to spin up a multi-zone Kubernetes cluster on your own laptop or whatever, which is kind of crazy. So you're going to need some kind of Kubernetes cluster. If it's not multi-zone, that's fine. You just won't get to play around with that feature. You're going to need Helm. And then optionally, you're going to need Step, which is a tool we like to use for generating TLS certificates. If you don't have Step, or if it's too annoying to install, and you can use like Brew, Homebrew, Brew install Step should work if you're on a Mac. If you don't want to do that, we're going to provide some certificates for you that you can use. These are the same certificates that everyone's going to get, so please, they're not secure. But if you don't want to install Step, that's fine. Okay, so hopefully everyone's got this in their brain, and then maybe we've got like a little banner or something we can put on the bottom that has this URL for so that people can paste it in with the next. I'll go on to the next couple slides. All right, so yeah, we're going to talk about Linkerd Enterprise versus open source. We're going to talk about some of the features, and then we're just going to get hands-on. We're going to jump right into it. I have two quick ads. The first is we do these Service Mesh Academies pretty much every month. I'm not usually involved because I'm too special and precious, and I also don't have any valuable information in my brain. But the next one we're going to do next month is we're going to talk about Linkerd 2.15, which is our upcoming release, which adds mesh expansion. That's the ability to talk to non-Kubernetes services and incorporate them into the mesh, and Spiffy and Spire support. So that's going to be really cool. So if that is something interesting to you, then sign up today. Go to Buoyant, click on Service Mesh Academy, and make sure you get a calendar invite for what we're talking about next month. We also have a brand new ebook. If you are really into zero trust and that kind of stuff, or if you have a friend or a loved one who is looking for, Valentine's Day is coming up soon. You want to give your special someone a zero trust ebook. Now is your chance to get it. It's free. It's technical, and it's full of love. Okay, one last time. If you want to follow along, make sure you have this repo. There's a directory in there called Hands-On with Linkerd Enterprise, and then make sure you have a Kubernetes cluster, the ability to run Helm, and optionally Step. Okay, and Jack, I see a message from you. Hi, Jack. He says hi from Florida. Hi from Texas. All right, let's jump right in. Jason, are you ready to do a hands-on thing when I'm done with these slides?
Not yet.
Not yet.
Oh, sorry. Almost. Too ready, William. I'm too ready.
Prepare your body for demo, for hands on. Oh boy, that sounds really terrible. Prepare yourself for this amazing experience. All right. So what's Linkerd Enterprise? So, the idea is that, hey, Buoyant, we make Linkerd open source, and then we also have this enterprise distribution. We want it to be everything that's in open source Linkerd plus a couple extra things that are kind of really tailored to the enterprise. So we do a couple things. I like to think of the things at the top as like kind of extra guarantees that we're able to put in place, things at the bottom as extra features. And most of what we're going to do today is play around with these extra features. So that's the exciting part. So, we do have a kind of a separate build pipeline for this. It has a lot of testing in customer specific environments and things like that. So we kind of produce these hardened images. We can ship SBOMs and things like that for your compliance teams. We can sign up for SLAs around CVE remediation. So if you're really running Linkerd in a mission critical place, that might be really important to you, and really only able to do that in kind of the enterprise distribution. And then we have some extra features. We've got FIPS compliance, which is either something you can happily ignore or something that's critical for you. We might spend 5 seconds on this because there's not a lot to demonstrate here. We've got lifecycle automation in Linkerd Enterprise. I think that is that's definitely one of the things we'll play around with, and it eases a lot of the pain of keeping Linkerd up to date, with all the latest security patches and stuff. And our goal here is to basically reduce your toil. We've got the really interesting feature called High-Availability Zonal Load Balancing, or Zone-Aware Load Balancing. And I have 2 slides where I'll talk a little bit about this. But basically the idea is you can eliminate cross AZ traffic, kind of in the same way that topology hints does, if you're familiar with topology hints, except topology hints basically has requires you to sacrifice some reliability to get there. With HAZL, we can give you the best of both worlds, and we'll see a little demo of that in action. Actually, you'll be able to try it on your own. I don't know why I keep saying demo. And then finally, we've got security policy generation, so we can take you from kind of the amazing and powerful, but maybe daunting set of security policies that Linkerd provides, and just make it really easy to get bootstrapped with a functioning application. So we're going to play around with all those features. The way the free trial works is you're going to sign in. You're going to get a version of Linkerd Enterprise that works for, I think it's 2 weeks by default, but you can always contact us and say, hey, I need to extend this. You're going to get the full functionality, except I think we don't have FIPS compliance in here because it's complicated. And it's not really super tangible anyways. And it's going to include Buoyant Cloud, which is cool. So you'll kind of get access to the full set of Buoyant Cloud features for about 2 weeks. And then after 2 weeks, everything breaks and everything stops working. So, don't let that catch you by surprise. All right, Jason's going to take you through lifecycle automation. It's basically a Kubernetes operator that can install Linkerd, that can upgrade it, downgrade it, that can manage your data plane as well as your control plane. So that's kind of nice. So when you upgrade Linkerd, it'll do the control plane first, and then it'll flip all the proxies on your data plane, and it'll do it in a way that's like safe and sane, and make sure the versions don't skew beyond the allowed tolerance and things like that. And totally compatible with Flux and Helm. So that'll be fun to play around with and should save you a lot of pain. Jason's also going to take you through policy generation, which I mentioned. I'm not going to spend too much time on this. It's easier to see this in action, I think, because you basically need a running application. We'll take you a little bit through Buoyant Cloud. There's a lot here because there's a lot of dashboard functionality, but there's also a lot of kind of alerting and monitoring. We'll give you a very brief overview here. If you do have your free trial running and you have your couple weeks of playing around with this thing, there's a lot to explore here. So click around. And then kind of the maybe the most interesting, if you have multi-zone clusters at least, is HAZL, and we'll see Jason will walk you through how to activate this. And we've got a little sample app. In the past we've used Emoji Photo, but we have another app called the Paint app, or Color Picker app, or something that's kind of a little more exciting to demonstrate for HAZL. This is the one where if you want to play around with this live, you're going to need a multi-zone cluster. So either have one that you've spun up on your own, or again, go to the GitHub repo and use K3D with our config, and that config will spin up a multi-zone cluster right on your very own laptop. All right, cool. So, I'll skip over this. That's like the pictorial version. I'm happy to talk about, why HAZL is better than topology hints, but really, I think at this point, we should just jump right into it and start doing the fun stuff. The way we're going to do this is you can start with URL here. Jason, do you want me to walk through this and demonstrate to people how this works?
Yeah, if you don't mind. So everyone as you're out there, if you plan on following along, if you go to this URL, you'll be able to actually generate some credentials that you can use to follow step by step through what I'm doing. And also at the bottom of the screen right now, you'll see a GitHub link. If you go in there and you CD into the hands-on with Linkerd, whatever it is, folder, you'll be able to go step by step through what I'm doing.
All right, so let's do this. I'm going to have to share a slightly different screen here, which is this one. All right. Okay, so I've typed in this URL at the top. We ready for action?
Let's do it.
Okay, so this takes you to a little account creation page. You can sign in with, what are these options is easiest for you. I'm actually going to do it the good old-fashioned way. Let's see. I'm going to, what's 2024, 18. And then I'm using my personal email address because I don't want, the NSA to know what I'm doing here. And pick a password. Let's see, I love Linkerd, something like that. Okay. All right. So I'm in. What's my name? Got to remember to spell it correctly. And then, this is the name. You kind of just pick whatever you want. Williams Playground. Linkerd Enterprise Playground. Here we go. Okay. Don't read any of those terms of service. Just agree to them. And once you're through there, you basically should see, and just type in the chat or something if you have any trouble with this. Am I still here, Jason? I got a connection.
Yep.
Okay, weird. I got a connection lost banner from Restream. All right, I'm still here. So just if you have any issues with this, type into the chat and we'll help you work through it. There's also like a workshops channel on the Linkerd Slack. So if you're on the Linkerd Slack already, just type, or paste a screenshot or something into that channel, and we'll help you work through this. But by the time, if you manage to do this all successfully, you should get a bunch of credentials here. And these are actually, special credentials that are, just for me. So I'm not going to use this cluster for anything important. And then from here, you can copy these, you can paste them into a file or whatever. And then you're basically going to follow now this installation guide where we tell you exactly what to do. And so I'm going to pause for a second, and anyone who wants to try this live and hands-on, please get to this point and let us know if you have any trouble. And you're going to take it from here. Is that right, Jason?
That's correct. Yeah. So let's go through it and begin. So what we're going to do today, let me clear this banner out of the way. What we're going to do today is we're going to follow the guide here at the trial, Enterprise Linkerd trial. Sorry, let me put that in the chat. Oh, perfect. You're gonna go to this trial guide and we're gonna follow along this step by step. I've got a little script that I've written to make it a little bit easier to present. So feel free to follow along here or go over to that demo repo for the same thing. So let's just change what screen I'm sharing. And let's get into the terminal. All right, can you all see my terminal okay? All right, awesome. So what I've got here at the top, I've got a K3D cluster running. So if you look in that repo, that Service Mesh Academy repo, let's just show that one more time. If you look in that Service Mesh Academy repo, you're going to see a clusters folder, and inside the clusters folder, we have a HAZL.yaml. So you can use K3D to create a cluster using that YAML file. And if you look at the steps.sh file, it's got everything I'm going to do step by step. Now, to do exactly what I'm doing, I took those credentials that William showed in the free trial, and I put them in a settings.sh file and I put an export in front of everything. So you just export those things as environment variables, and then you can follow with exactly what's going on through the rest of it. All right, so we're going to source our settings file just to add all the variables we need in our environment. And then we're going to start by pulling down the Buoyant Enterprise Linkerd CLI. So we're going to curl it. I've already done this, so it's already available on my machine. And we can just check. All right, so I've got a cluster spun up in K3D with 3 availability zones, right?
And you're going to have to, you got to add that thing to your path too, right, Jason? Which I know you've already done, but this is the first time that you're curling this Linkerd command. You got to make sure that it's in your path, otherwise it's not going to work.
Yeah, great point. Otherwise, it won't work. Yeah, thanks for that. Thanks for that catch.
There's also a question from someone in the chat which says, "Is there a self-hosted option minus the cloud part?" Which is a great question. You know, maybe we should have talked about this, but everything we're talking about here is self-hosted. So everything about Linkerd Enterprise, except for Buoyant Cloud, you know, which is like the SaaS component, everything else here is self-hosted. So you install this on your own production systems. You run this. You know, it's like it's yours.
Right, and it doesn't require the Buoyant Cloud integration. Yeah. We are showing it, but you can just, if you just skip the Buoyant Cloud integration parts, that'll work fine. And there's actually steps in the doc site that tell you how to go through and install Enterprise Linkerd in a fully offline fashion.
Yeah, just like Linkerd, you know, just like open source Linkerd. It runs on your cluster. You know, it's not a SaaS thing.
All right, so here I ran the pre-check for Linkerd. So just validating that I can install Linkerd on this cluster. Everything looks good to go. So we're going to go ahead and actually do it. So I'll start by adding the Buoyant Cloud repo, running a Helm repo update so that I have all my bits there and going on, right? In my case, I'm going to set the cluster name as JMO SMA, but you can call your cluster whatever you want. And now I'm actually going to install the Buoyant Cloud agent, right? So I'm going to create the namespace. I'm going to give the agent a name. I'm going to set some special flags for metrics, and I'm going to tell it what client ID to start using, right? So we hit return, and this is going to begin installing the Buoyant Cloud agent and all its associated tooling. So if we look here at the top, we're going to get some new pods starting to appear. We're going to get a metrics agent daemon set. We're going to get a Buoyant Cloud agent deployment. We're going to get our operator, which is actually 3 pods, one that handles the control, or 2 that handle the control plane, 1 that handles the data plane. And we'll talk about how those work, and we'll see those objects in action in just a second. So now that we've hit the deployment, we're just going to wait for the daemon set to get fully up and running. And it looks like we're already done.
And these commands that you're typing in, Jason, these are all in that repo that we pointed out at the beginning, right? Like you can follow and just go through that. You don't have to rapidly, you know, type what Jason's typing.
Yeah, sorry about that. They're all there, and they're also in that trial getting started doc. So let's just put that in the overlay one more time. Yeah. So if you go to this URL, you'll see everything that I'm doing just written out. So you can copy and paste from there. And if you
can you keep that URL on there?
Yeah, absolutely.
Because people have to, you can't even copy and paste it. You have to you're gonna have to type that in.
Yeah, fair enough. And you know what we'll do? Somebody's going to go share it in the workshops channel. So if you get a chance to join the Linkerd Slack, slack.linkerd.io, go to the workshops channel. There we're going to paste this link right in there. All right. So now that we've got the Buoyant agent installed, we're going to go ahead and run a check just to make sure that it's good. So if we look through our check, we've got a couple of interesting things. So everything seems to report back green, but we see that the cloud agent deployment and the metrics set daemon set aren't injected. So that means they should have the Linkerd agent installed, but they don't, right? So we're gonna address that kind of towards the end. So give us a bit, and we're gonna get that fixed. And we're gonna actually use the data plane operator to do that for us.
And at this point, we don't have Linkerd installed yet, right? We have kind of like the harness. We've got the lifecycle automation components. We're now going to trigger like a Linkerd installation. Is that right?
That's right. So if you look at that getting started guide, it's going to tell you, that trial guide, it's going to tell you to run a big cat thing where it's going to substitute in some certificates for you. Before you do this, if you're using the step CLI, right, inside the docs, we have everything you need to install step and go ahead and create your certificates. If you follow along with the repo here, there are some certificates that already exist in the repository that you can just use, or these files are actually fully populated for you. So you can just use the certificates that we have already ready to go. So you can just do kapply linkerd identity secret.yaml, and this will work in your cluster. Just to see what's in there.
Don't use these in production.
Don't use these in any environment that you want to be at all secure, right? This is, everyone's got these private keys.
This is a free lock and key for your front door that we're giving, and we're giving the same lock and key to everyone who asks for it. So, not good security.
This is what our secret object is going to look like. So it's just going to have it's going to have the base64 encoded certificates for, we always have the public key for the trust root, and we have the private key for the private and public key for the intermediary certificate that the issuer uses. Okay, so that's our secret. We're going to apply it to the cluster here directly. And again, you can do this operation right out of that repo. This thing's already populated. And now we're going to take a look at the control plane config. Before I go too far, do we have any other questions? Oh, people asking about that. All right, no more questions in the chat. All right, great. Let's look at the control plane config. So this is the file that we're going to use to actually install the Linkerd control plane in our environments. This is what's going to get us our enterprise Linkerd. So let's take a look at that. So we have a Linkerd object, and it's called a control plane object. The control plane object instructs the control plane operator to install Linkerd using the credentials and using the values that you put here in this object. So if we look here, we're installing preview 24.1.23. Right, so this is that preview build that you can see with that high availability zonal load balancer enabled. We've got a license key that you'll use. This will change it to be your license key, or if you don't do anything, you're just going to use my license key, which whatever. Welcome to it. We set the proxy version, right? So we're using that high availability zonal load balancing proxy. We're setting our public key, and then otherwise we're just telling Linkerd to use that certificate we created earlier. We also have this experimental argument right here. So this here is actually enabling that zonal load balancing that we're going to see in a bit, right? So this is the flag if you want to toggle that on and off. All right, well, let's apply it and let's see if it works, okay? So we're not going to install Linkerd ourselves. We're going to rely on the operator to do that for us. So we hit kapply Linkerd control plane, and we should see in a second some new pods start appearing on top. And right on time, guys. Good job. So we see the pods starting to run. We're going to run a Linkerd check. It's going to validate that everything's good. If there are any questions, I'd love to answer them now. If not, y'all are going to hear a very bad networking joke that you may have heard before.
If you were, if you were doing this in like a GitOps land, part of what's in that CRD is the version, right? So like, what would you do if you wanted to upgrade Linkerd in a GitOps compatible way?
Yeah, so you'd have your GitOps tool, whether it's Flux or Argo rollouts or whatever you're using, would, instead of managing a Helm install for Linkerd, it would manage that control plane object, right? And as you set the version on that control plane object, the control plane operator will then go and upgrade or downgrade the Linkerd control plane to match that version. Okay, so that's the basic flow there, right? And at the same time,
end up with a Git commit that basically changed like a .3 to a .4, and then that would go through the regular pipeline, make its way onto the cluster, and then the operator would take care of the rest.
Absolutely. Okay, with that, we now see that our checks are complete, and we have status results, or status checks are all green. So we're happy. So it's still complaining that the Linkerd Buoyant namespace doesn't have everything injected that should. So we're gonna get to that in 1 second. First, I'm gonna install the Emoji Voto application, let it take a second to gather up some data, and then we're gonna create policy for it. So let's do that. There we created our Emoji Voto apps, or our Emoji Voto components, and we're gonna come back to that in just a minute. Right now, we're going to address the fact that that Linkerd Buoyant namespace has a number of pods that should be injected but aren't. So this is a data plane object. The data plane object works by, we've got this spec workload selector, and we decide what labels should we match. In our case, we're matching all the pods inside the Linkerd Buoyant namespace. And what we're saying is, if you are supposed to be injected, the data plane operator is going to make sure that you do have the proxy that matches the current version of the control plane. So if your trust root changes, if your Linkerd control plane changes, this tool, or if you're not injected for some reason, this tool will go through and restart your pods to make sure that you have the Linkerd proxy that you're supposed to have. Again, we're just going to make sure that we're up and ready. So we check on the Linkerd Buoyant daemon set. It's rolling through and updating, and then we're going to go ahead and run a Linkerd check to validate that those proxies are in the right place.
Does anyone need us to slow down or to help you get caught up? Please give us some kind of signal in the workshops channel or a comment or something.
Yeah,
we do this all day long. Typing these commands we can do in our sleep.
It's true. I don't even type at this point. All right, so we've rolled out the Buoyant Cloud agent. Let's just go validate that the proxies are healthy in the Linkerd namespace. And just because I saw another question in there, you can automate this deployment using whatever your CI/CD tool is, right? It doesn't matter what you're using to apply. As long as your tool can apply objects to Kubernetes, then you can manage this control planes and data planes. Yeah, and so Raghunath, you're right. Yes, you can use Octopus deploy to do this, right, across multiple clusters. You have to have the operator installed in each cluster, and then you apply the object, and you're good to go.
And David says he's got lots of detailed questions, but this is like a high level, make it work sort of event. So yeah, I think that's a fair characterization. We'll be around for all the detailed questions. We're here.
Yeah, and yeah, don't be shy if you have more questions. We're happy to dive in. All right, so with that, we can see that now if I look at my Linkerd Buoyant namespace, the metrics agent and the Buoyant Cloud agent have all been restarted. And instead of having one container per pod, they all have two, because these ones are subject to Linkerd injection, whereas we see my operator in the same namespace didn't get restarted, didn't get modified, because it's not meant to be injected. So that data plane operator is smart. If you tell it to apply to a namespace, it will only restart pods that are supposed to be injected when they're not, right? So we can safely apply it to all namespaces in our cluster. Now we're going to use some policy generation. So what I want here, let's talk about this a little bit. I've got this Emoji Voto application, right? And if I'm using Linkerd for mutual TLS, it's pretty good, because I have encryption in transit, and I know the identity of everything that's talking to everything else.
Pretty good, Jason. It's incredible.
It's incredible, but what's a lot better than that is using that TLS identity to say who should and shouldn't be talking to whom, right? The problem with policy is it can get really complicated, right? And we need a lot of objects to properly secure things. So what we've done here in the enterprise side is we built a tool that automatically evaluates who's talking to whom and creates policy objects for you, so that all your application ports have the objects they need to start securing your workloads. So let's take a look at that real quick. So I'm running Linkerd policy generate, and I'm piping this directly to kubectl apply. So it's going to look for my application namespaces in this cluster, and it's going to generate policy objects for me. So what I can see here is that I have server resources, mesh TLS authentication resources, network authentication resources, and authorization policy resources being generated for all the server components in the emoji photo namespace. So stepping back really quick, policy applies. When we think of a conversation between microservices, we have the client and the server. Policy is applied at that server side, at the component that receives the traffic. And so now what we've done is we've created a server resource and the paired authentication resources for web, the emoji service, and the voting service. And we're going to take a look at that in Buoyant Cloud in just a second. And here's my reminder to do just that. So let's go change what we're sharing.
Yeah, let's see some pictures. It's too much text.
Too much text, more pictures. Got it.
My old brain is tired. I need some pictures to look at.
Okay. All right. So now we should be looking at my browser. I'm going to narrow it down to just what we want to look at. So let's look at Emoji Photo. So Emoji Photo, we've got our VoteBot component, which sends traffic to our web service, which sends traffic to emoji and voting, right?
And if you want to get this view, in Buoyant Cloud, you just click on the topology tab over there, or what do you do?
Yeah, that's exactly it. So you'll start over here on Overview, and then we're going to hop over to topology. In my case, I'm filtering down to the Emoji Photo namespace so I can see just what I wanted to see here, and we can get a view of our applications, right? And so we can see who's talking to whom. We can see that there's a bit of a degradation on the voting service, right? So something is wrong with the way voting works, which if you're familiar with the Emoji Photo application, you've probably seen that once or twice before. But we can see in our flow where our problem's coming from. And we also see what our traffic is. Speaking of which, let's go over to the actual traffic page and let's look at this Emoji Photo application. So now I can see, looking at the active application ports in this namespace, which is 8080 for all my apps, I can see that I've got VoteBot talking to web, I've got web talking to voting, and I've got web talking to emoji. For all of them, I have the default policy of all unauthenticated. And for each one, I have a policy object that explicitly is allowing or not allowing traffic. So let's take a look at web. So for my web service, we do two things. We explicitly allow MTLS traffic from the default service count, right? So the VoteBot uses the default service count in the Emoji Photo namespace, and it's allowed to talk to the web service. If I'm an Nginx ingress controller, if I'm any other component in here, I'm not going to be allowed to talk to the application port on the web service, except for we built this other rule that allows any traffic from any IP address. So our automatic policy generator is intended to give you that head start on building policy, but also be safe to apply. So if you just do exactly what we do in the demo, where we generate the policy objects and apply them to Kubernetes, you're not going to find things start breaking. In your actual environment, you're going to have to decide what IP addresses you'll want to be allowed to talk to things in your cluster, right? And you're going to create network authentications that match those IP addresses. So this is a safety valve for the auto policy generator. In real life,
for example, if you have application components only talk to each other every 24 hours, and you run this thing after 1 hour of traffic, then you're not necessarily going to capture everything. So you have to be a little intelligent, before you remove that fail-safe valve, you have to be a little intelligent and intentional about, whether the policy is accurate. But it's a bootstrapping mechanism.
Absolutely, right? Like policy is, it's the only thing we've given you in Linkerd that allows you to break your own applications, right? So you want to be really smart about the way that you do it. So that was web. Now we can look at voting or emoji. They're all going to be the same because they're there to just allow the web service count. So VoteBot, if VoteBot wants to skip web and send to emoji or voting, it's not going to be allowed because we're only allowing MTLS traffic over from the web service count. And that's how we harden that environment. And you can use policy generate to build that for whatever your applications are. And it's a way to get pretty far ahead on policy generation. Okay.
Jason, could you go to docs.buoyant.io real quick? Because we kind of skipped over this really quickly, when we first got started. But policy generation, if you go to tasks, for example, down there, there's a whole task there, generating authorization policies, where we'll walk you through exactly how to do this thing. So of course you can watch a video and so on, but we've got a lot of docs as well for when you're doing this, at home.
Yeah, great. And there's other things if you want to download the SBOMs or whatever else it is, right? And these are all the steps for how that works.
Yeah, there's a lot in Linkerd Enterprise, and we're rushing through like some of the fun features, but there's a lot more out there.
Okay, now let's go back to the terminal and see what's next. All right, you able to see my terminal again? No, you're not.
Can't see nothing. There we go.
All right, so that's policy generation. We've got the operator installed. We've got it working to manage our proxies. We've got it working to manage our control plane. Now let's see that high availability zonal load balancer in action. So we're going to deploy a new application. And again, if you're following along in that GitHub repo, this is in the colors folder. So we're going to do a kapply-k on the colors folder. And this is going to create a namespace. It's going to create a bunch of different applications. And let's change our watch here so that we're looking at something a little different. We're just going to look at pods in the colors namespace. All right. So the way colors works is our brush pod is going to send traffic to the paint service. Blue, red, and green are all members of the paint service, but each one is bound to a different availability zone in our cluster, right? Just in this setup, and if you look at the HAZL.yaml in the clusters folder, you're going to see a K3D config that allows you to spin up a 3-node cluster or 4-node cluster with 1 node per availability zone. Availability zones A, B, and C. So we've got the brush pod here, and it's running on agent 1. So if HAZL's working, we're going to see traffic go only to green and not to red or blue. And if we turn HAZL off, we'll see the traffic go otherwise. So we go back to our topology view.
So in this topology, Jason, brush is like generating traffic.
Yeah, brush is generating traffic.
The blue, red, and green are 3 like servers that receive that traffic.
That's correct. So we see by default, brush sends to blue, red, and green. And when HAZL takes over here, we're going to see us. Oh, sorry, I'm not sharing the right screen. When HAZL takes over,
makes it difficult to bounce back and forth.
Yeah, it's not as smooth as we'd hope, but okay. So here we've got the initial view of brush sending to blue, red, and green. But what we're going to see here is as time goes on, HAZL picks up. Initially, we start routing to all of them, but then we realize who's in zone and who's not, and our traffic is going to shift so that everything goes instead of going balanced evenly across all 3. We're going to stick in zone whenever possible. Right, so we can see now that blue and red are falling off in terms of traffic, and green's picking everything up. And I know that could be a little bit hard to see, but we've got another view here, which shows it a little bit more simply. Right, so we can see the 3 workloads in this namespace are blue, red, and green is getting all of our traffic. And so that's HAZL in action. Now, if I delete the green pod, we're going to see things shift around. So we can actually do that real quick. Delete pod -n. I'm doing this in another screen so we don't keep hopping back and forth. But believe me that green is going away. So as we delete the green pod, what we're going to see is in the interim, we're not going to have our success rate dropping off, right? Instead, what we're going to have is traffic shifting to go a little bit to blue and red. Right? Or we could even scale green to 0, right? And we'll see all traffic shift away to the others. And if we look at metrics, we should see a little bit more traffic go.
So the idea here is that under normal conditions, we want to keep all the traffic within the same zone, because if you're running in the cloud, if you're running on Amazon or Google, you get charged for cross-zone traffic. So, you've got this beautiful multi-zone cluster, which is great and highly available and resilient to zonal failure. But under normal conditions, Kubernetes is going to spread all the traffic out across zones, and then you're going to pay a bill for doing that. So under normal conditions, what HAZL will do will keep that traffic into the same zone. But when the system goes under stress, a lot of traffic, more traffic than one zone can handle, or, like what Jason's doing, one component dies in a zone, then HAZL will allow cross-zone traffic. So you kind of get the best of both worlds. And that's what we're seeing here is, the traffic to the green is going down because that pod no longer exists. And HAZL's now shifting traffic onto blue and red. So you get the best of both worlds. You get cross-zone, you get cost reduction when things are healthy, but you don't sacrifice reliability when things do go unhealthy.
Yeah, exactly. Now we're going to scale green back up, and we'll see this heal, and all the traffic is going to go back to green, and red and blue are going to be seeing 0 requests per second. And yeah, you see that shoot up. Well, right now we're seeing blue, but we're about to see that shift back over.
David says, "Oh my God, this is amazeballs. I've been looking for how to do this limit cross-zone stuff." Okay, good. Well, thanks.
Yeah.
Thanks, David.
And there's like you've seen me do all the configuration that I had to do, right? You enable it and you go, right? I'm not tuning this on a per service basis. I'm not. I didn't mark anything special on these workloads, right? Like the only special thing here is this particular deployment's broken up across 3 AZs instead of just one deployment that would have been multi-AZ. You can see it too if you look in that repo. There's a flag, or there's a command to do emoji voto. So that's a version of emoji voto that puts 3 pods for each of the workloads in different namespaces, and you'll see the same thing where it only goes to the in namespace emoji voto without having 3 different deployments. So poke around.
Yeah, this has been a really fun feature to develop because Linkerd is in such a good position to make these decisions. Not only is it able to route things on an individual request basis, but it knows the latency of the endpoints. It knows the success rate of the endpoints. So we see all these interesting behaviors where even, before things start failing, if latency starts increasing, HAZL's able to kind of preemptively send cross-zone traffic because the system starts getting towards a stressed state, even though it hasn't quite gotten to failure yet. So it can be, and the responsiveness, the metrics here, there's like a metrics pipeline delay, but the responsiveness of the proxy is very, very rapid to these conditions. Yeah. So even if things are fluctuating, it'll adjust very, very rapidly. You see the metrics, kind of smear that over larger timescales, but the proxy itself is able to respond very, very rapidly.
Yeah, and this works on EKS, GKE, AKS, wherever you happen to be, right? I've certainly done a bunch of testing on GKE myself, right? And you can see it work just as instantaneously as you do on a K3S cluster. All right, yeah, and we see now back on the metrics that we've recovered, and everything's going to green, which is what we'd expect based on the distribution of pods.
You can make a little estimate of how much you're paying for cross-zone traffic because it's basically 20 cents a gig. So if you know the amount of traffic you have on your system, and you know the number of zones, and you know kind of the payload size, you can multiply that all out and say, okay, I'm spending $1,000 a day on cross-zone traffic, or I'm spending $1 a day, or I'm spending $10,000. Like it depends on kind of traffic volume. But in some cases, this can be, kind of a massive cost reduction. The other thing that we're not really going to explore here, but that HAZL's capable of doing is cross-cluster traffic. So you can preserve zone locality. Yeah, David says, or you can just look at your bill. Yes, if you're on GCP, you may actually have a bill that you can parse out. If you're on AWS, you're going to need a consultant to help you figure out what that bill really is. But yeah, if you have multiple clusters with it that are all cross-zone within the same region, that cross-cluster traffic, you can also, with Linkerd Enterprise, you can also pin the zone. And so we have some customers for whom the traffic within a zone or within a cluster isn't that big of a deal, but they have cross-cluster traffic where they really get hit by cross-zone billing. And so this is a lifesaver for them.
Yeah, so SR, sorry, I don't know your name there, asked about what conditions are there for switching traffic between zones. Essentially what you have under the hood is a threshold that understands like how many requests you have in flight at any given time. And we say that if you're within this reasonable number of requests in flight, we're going to leave everything in zone. And as you grow beyond that limit, you're going to start seeing some traffic escape the zone. So essentially the load balancer just only has in zone endpoints to route to as long as you're within tolerance. Once you go beyond tolerance, you're going to start adding pods to the load balancer that aren't in zone. So you're going to see some things go to blue or red or whatever as you increase the traffic flow.
Yeah, and that request and flight metric is resilient, is resilient to changes in latency, to changes in success rate, to changes in someone else talking about SR also talking about auto scaling. As you add more pods, Linkerd's load balancing, so that number will go down. So all of that stuff kind of gets taken into account by this one metric.
Yeah, and we can increase the number of requests and see it go out of zone. But that's really about the whole show.
Yeah, great. Gosh, so we got through all of these features in record time, and special gold star to anyone who was able to follow along live with us, because I know, we went through this stuff pretty fast. But everything that we did today is available in that Git repo if you want to do it, if you're watching this as a recording, or if you want to do it again with a little more time on your hands. And these free trials are available for anyone who goes to that site. So please kick the tires on this thing and give us some feedback. And if you have deep questions, actually, and I see interesting questions from SRN, from David here, which maybe we'll answer in a second. But if you have deep questions, just drop them in the workshops chat, or somewhere on the Linkerd Slacker. We've got forums too. We've got Linkerd.buoyant.io is actually a forum. What's nice about the forums versus the Slack channel is Slack disappears after 90 days. So we'll go through this whole investigation. We'll figure out the root cause, and then all that delicious information will get thrown into the void. But on the forums, these things last forever, and they're searchable by Google. So yeah, thank you, for everyone who's asking questions on these forums, because it means posterity gets to benefit.
If you're following along in the repo and you have any questions, you can see in the cluster we've got the config for K3D. Back here in Hands-On Enterprise, you have the color app if you want to deploy it exactly as I did. You have the emoji photo app if you want to set it up so that you've got multiple instances that run in different availability zones. And you have the exact steps that I followed as part of this repo right here in the script. We also have the stuff in there for Demo Magic if you just want to press buttons and let it walk through for you, which is what I do, so that I don't have to type in front of the internet.
All right, we got a couple of questions, and we still got a couple of minutes, which is great. So the first question from Oleg on the Workshops channel: would you guys mention FIPS 142/3 compliance as promised? Yes, I will mention it. So we didn't demonstrate it today, Oleg, because there's nothing really visual to see about it. Although, Jason, if you have a terminal open, you could run that FIPS audit command, and it'll say XXX. No, you don't have FIPS mode enabled. But the idea is that for FIPS compliance, and I'm going to summarize this very, very briefly. It's a set of standards that define, like, hey, here's the types of cryptography you're allowed to do, and we have a build of Linkerd Enterprise that is FIPS compliant. And we have a little audit command that'll, kind of validate that that's what you're running or not. You only care about this if you're selling something to the US government or to some of the other government bodies that have adopted the standard. But it doesn't actually change anything about the nature of the communication. There's no visual effect there. It's just, do you have an implementation that conforms to these standards? And doing this is like extremely hard, and not for great reasons, but it is a requirement for many of our customers. So yeah, Oleg, if you've got more questions about that, please shoot us an email or a DM, and we'll tell you more about that. We've got CMVP numbers and like all that stuff. All right, let's go through some of the questions on the stream. So topology aware hints. You want to answer this, Jason, or should I tackle it?
Yeah, well, let me give it a shot, and then you can correct what's needed, right? So topology aware hints in Kubernetes essentially So they're both there to accomplish the same thing, right? Like they both want to make it easier to send traffic in zone whenever possible. The difference between topology aware hints and this high availability zonal load balancing in Linkerd is, what does the pod see, right? So with topology hints enabled, what you do is you essentially limit the endpoints that a given service gets, right? And you have a bunch of requirements with it, right? You need three pods per zone and some other things there. And it ends up being a little bit brittle in what it can do, right? With HAZL, what we see is, as long as there is a pod in zone, we can prefer you route there, right? There's no special configuration needed. We'll just go and route you in zone. And when we see that in zone pod is getting slammed or is too busy or is having issues, we can use Linkerd load balancing to move you away from it. Whereas when you're using topology aware hints in Kubernetes, if you go to 10,000 requests to one pod in one zone, you're always going to be stuck there, and it won't be balanced over other zones. William,
I think that's the fundamental difference. Topology aware routing or topology hints doesn't allow cross-zone traffic under any conditions. It works by filtering out the set of endpoints, at the IP address level, and says, okay, if you're in this zone, here are the endpoints that you get, and it doesn't matter, whether that set of endpoints is capable of handling the load or whatever. So you get the benefits of reducing cross-zone traffic, but you sacrifice reliability. And that's actually the whole reason why we went down this path in the first place, is because we started out with topology aware hints and quickly ran into all these issues with them, where you were basically required to sacrifice reliability. I'm writing a blog post about this with a lot more details. So David and Andre and other folks were asking about this. I'll try and get some more of the technical meat out there for you. But yeah, right now it's you basically sacrifice reliability to do that.
So in my example here, what we did is, originally we were running 50 requests per second. And at 50 requests per second, everything went to green. We kicked it up to 300 requests per second. And the proxy decided that green can no longer serve everything fast enough. So it's balancing requests against blue and red and green. So at 300 requests, we're much more distributed. At 50, everything goes in green. And that flexibility is the difference, really, right? Like that dynamic shift around as we need to.
All right, so let's see. Andre asks, do Linkerd and topology aware hints interact, or does it supersede? So yeah, Linkerd can run with topology aware hints, so can Istio, so can any of these service meshes. That's a Kubernetes feature that all these things will respect. They all kind of do the same thing, which is those endpoints get limited, and Linkerd will obey those limitations, right? So Linkerd with topology aware hints kind of has the same behavior as just stock Kubernetes with topology aware hints when it comes to, do I ever talk across zones, right? So anyone who follows the topology aware hints kind of has that. There's a bunch of other things, if you read through the topology aware hints docs, there's like, here's the 6 ways where things go wrong. If you don't have enough endpoints, if you have imbalanced endpoints, if you're using auto scaling, like these all interfere with topology aware hints. So there's all these kind of edge conditions. But yeah, the major one is the sacrifice of reliability.
And just
hopefully that answers your question, Andre. Okay, let's see. A lot of good conversation here. The Linkerd dashboard and monitoring system part of the cloud is not available. I'm assuming, so SR says, I'm assuming Linkerd dashboard and monitoring system part of the cloud is not available in the open source version. Jason?
Is not available in the open source version.
I think the Buoyant Cloud
this Buoyant Cloud dashboard, yes. Buoyant Cloud dashboard is, well, so you can use Buoyant Cloud with open source Linkerd, you can use Buoyant Cloud with enterprise Linkerd, right? So it's available for either, right? It's available for either case. That operator will work with both open source and enterprise Linkerd. Of course, there are features in enterprise Linkerd that aren't available in open source, but yeah, the dashboard works for both. David mentioned that the open source dashboard is simpler. It is, and it's significantly different, right? The Buoyant Cloud tool is meant to be, a lifecycle and health and operational dashboard for Linkerd, right? So this is a tool that if you want to ensure that you'll know in advance before you have an outage with Linkerd, that's what Buoyant Cloud is intended to do, right? Like we run a lot of Linkerd for a lot of folks. And as we know what goes wrong or what could go wrong, we convert that into alerting rules in Buoyant Cloud that we run against your environments. We find ways to surface data that we find useful and that our customers find useful. So yeah. Let's see.
And Andre asks, is HAZL Enterprise version only? Yes, that's Enterprise only. All right. Any last questions? This has been a great, got about 2 minutes left. Great set of questions for everyone so far. Anything on the workshops channel? I haven't been distracted.
No, look like we're okay for now.
Yeah, great.
Origin of the name HAZL. Yeah, so it's HAZL without an E. William, you want to go into that?
High-Availability Zonal Load Balancing. And I didn't want to call it HAZL, but so HAZL.
Yeah. It was the best. I think it was the best acronym of the ones that we tried.
It was the least worst one.
There you go.
All right, Jason, why don't we wrap it up here? Thanks everyone for some awesome questions, and hopefully you were able to make it through the free trial yourself. This stuff is all going to remain out there live and ready for you. So if you want to give it a try tomorrow, it's still there for you. And please, shoot us questions on Slack or on the forums if you get stuck on anything.
Yeah, that workshops channel stays open in between. Feel free to just tag me if you're stuck on something. You should be able to run through that. You should be able to run through that setup as is now. There's some tools that I use that you might not already have installed. So ask and we'll talk to you there.
Awesome. Thanks, folks. And don't forget to register for the next one if you want to hear about mesh expansion and Spiffy and Spire support in Linkerd. That's coming up pretty soon.
I can't wait. All right. Have a great rest of your day, folks.